Alrighty, just wanted to do a quick demonstration showing how we've set this circuit up for the OpenZmeter and simulating an IEEE ComTrade file using the Doble Power System Simulator and software. Just kind of want to first start out what we got going on here. This is the Doble Power System Simulator. As you'll notice, we have a battery simulator that provides a steady DC quantity to the meter to keep it powered on like it is right now. And I'll show how that happens in the software. And it actually wires into this terminal. And then you can also see we've got two circuits here. Red is A phase, yellow is B phase, and blue is C phase, and then the black is the neutral. This is a YY connection to both circuits. One of these is a current metered circuit, and the other one is a voltage metered circuit. We'll start with the voltage side, which plugs directly into the meter. And you'll see the lines from left to right, A phase, B phase, and C phase, and then next to them is the neutral, which is tied on the back. And I'll go over here real quick. The neutrals are tied for that Y connection. And then you have this Schweitzer 735 revenue meter that really is just acting as a terminal for the circuit to be observed for injected currents. And you can see it's got the A phase, B phase, and C phase, as well as that Y connected, those connected neutrals that go back to the power system simulator. And the way we're measuring these injected currents is through current transducers. As you can see, they're connected down here at the bottom of the OpenZmeter. And we have, this is not a permanent setup. You see you have one on the A phase, one on the B phase, one on the C phase, and you can see the arrow is pointed back at the source. Make sure those are connected correctly. And what we're going to do is we're going to go back to the desktop where the software is set up. So you can see you got the USB connected back here. And I'll just kind of go over what I do to set this up each time we want to run a simulation. So I'll close out of this. So I go to this protection suite where I opened it up. English. Okay. So the very first thing I wanted to do for our battery simulator is I want to go down here to this quantity. Well, actually, first, what you want to do is you want to verify you have the simulator connected to the right port. So I'm using serial port COM2. I know it's COM2 because I just verified it a few minutes ago, but the way you test that is you just, this is green, so it means that it is connected to COM2, but you can verify. It'll change to red for a moment while it tests, and it will change back to green because that's the one the simulator is hooked up to. Back what I was saying about this, though, I want to set a DC quantity for the battery simulator to keep our meter on, so we can work on it and don't have to simulate it constantly. 125 is within the DC rated range to supply the meter with enough power to keep it on. So I'm just going to enter that value in there, and I'm just going to press a 1. And I don't know if you can hear, but you can actually hear the power system simulator powering up and supplying that voltage. And that's why our meter is on. Okay, but back to this. So the way to run a simulation is you would go to test plan, and you would hit this little drop down, and you go to transient playback, and you'd hit with ComTrade file. And we actually have quite a few of these provided by TVA's Power Quality. We'll do this one that's Colbert Fossil Plant. So you can see we've entered it into there. So now the next thing is to go here to test 1. I'm sorry, I may have not seen that. So you go to test 1 up here, and now we need to map out our ratios, right? So this is 1-to-1. We're not going to inject the 1-to-1 because it would be injecting primary values. So for current 1, for example, we want 200 to 1. This is just an example. And then 2000 to 1 for VA, VB, and VC. And then we got our other two current inputs, and they are going to be 200 to 1. Oh, okay. So we should be good to go there. So you're dividing all the voltage signals by a factor of 2,000 and dividing all the current signals by a factor of 200, which gives them into a tolerable secondary device quantity. Okay, so the next step is actually just to run the test. So we just go up here and we hit run. It's going to ask us, let's see if we can hit OK. Yeah, so you can hit OK, and it's gonna begin to run the test. You can actually hear the simulator. We'll walk over here while it's simulating. So it's actually running the test right now. And that's how you run the simulation. We're still working with the OpenZmeter device owners, but once we get on to the next steps, we have this the device actually connected to the internet, and we're at the device's website right now. You can't access this unless the meter is connected to the network, so that's how we know we've got a successful connection. And when we're able to get on to the next steps, configure the voltage inputs and voltage inputs and current inputs, then we'll be able to display the results